Hey guys, welcome to day 81 of Codeforces Everyday until GM. Today we're going to be working on this question. I looked at it a little bit today, but I wasn't able to get it. This is actually the question of the day from my Discord server that I started for y'all. Y'all guys on YouTube, if y'all want to talk to me or like ask about Codeforces problems, I started this server. And yeah, this is the problem of the day today. Feel free to join. I'll leave the link in the description below. Make sure y'all read the rules and then select your roles. Would be much appreciated. All right, back to this problem. Informatics in Mac. In the Master's Assistance Center, Nam Nam was given a homework assignment in informatics. There is an array A of length n, and you want to divide it into k is greater than 1 sub-segments in such a way that the mex on each subsegment is equal to the same integer. Help Nam Nam find any suitable division or determine that it does not exist. A division of an array into k subsegments is defined as k pairs of integers, blah blah blah, such that yeah. Okay, I'll explain to y'all what this question means. I've already gone ahead and taken in some input. Basically, what it's saying is, given an array, you want to split it into k segments. K is however much you want, as long as it's greater than 1, such that each segment has the same mex. So in this case, we can split it right down the middle. Let's pull up an inksync. 0, 0. Split it right down the middle. Both these sides have a mex of 1. If we have 1, 2, 3, 4, this is impossible. Because no matter where you split it, like if you split it here, this mex is 1, this mex is 0. And then moving on, no matter how you split it, all these mexes are 0, whereas this just increases to 2, 3, 4, right? So we can see pretty clearly this one's impossible. And then finally this one, they give this example of splitting it into 3 cases. So let's just write it out, 0, 1, 7, 1, 0, 1, 0, 3. They split it into 3 cases. I think it was something like this, so that the mex is 2 for all of these. But this is actually the most important case here, because the intuition is, if you split it into 3 cases, you can really merge this middle case with any of the side cases to get the same mex, right? Like if you have duplicates in a array and you're looking for the mex, the duplicates aren't going to affect the mex at all. So for example, if we just split it like this mex is still 2, and this mex is 2 as well. And then if we split it here, this mex is 2, but this mex is 2 as well. So that's how it goes. So now we need to check when it's impossible. And like, okay, my original intuition for this question was some sort of 2-pointer approach where you build the arrays from the sides and then you slowly increment out until, or like you would check which side had the smaller mex. Since this mex is 1, this mex is 0, we start building from here. Mex is 0, now they're equal. And then if they're equal, you'll have some sort of check as well to start like building and building until you have the mex. And if the mex is equal on both after you've iterated through the entire array, then you have your answer, right? If it's different, then it's -1. Unfortunately, some sort of implementation error came out of that, so that may not be the way to go about it. But I was talking to one of the members in the Discord about this question earlier, and I was thinking about like some sort of mex pre-computation. Like you find the mex of the whole array, and then you just slide the indice of where you're splitting it. Like for example, you have 0, like we can split it here at first, find the mex, they're not the same, so we slide it here, find the max. They're not the same, and then we keep sliding it until I think here they both have the same max, and then we can just return this result. So this would be from 1 to L and then R to N, right? And then we would just always print from 1 to L and then print R to N. Right, but these variables aren't defined, so let's go ahead and define them. L equals 0, R equals N minus 1. I'm trying to think if I need to add 1 to anything, but we'll figure it out after we get the logic in. So let's start by just computing the frequencies for the arrays. We can do that from count equals, we've done this before in yet another max problem, right? Something like this. Bang. And then to find the max, we can do something similar here, like cur max is equal to 0, and then while count cur max plus equals 1. Yes, count. And then now what do? We have to define an array, left R, left max is going to be equal to 0. Let me think. Now we iterate through the loop for I in range, and we want to move this bar from left to right, so we have to update the right side by removing from... Technically this is the right side array, right? And we're building the left, so let's rename this to right R. Currently right R has everything and left R has nothing. So while right R, this is cur max, let's call this right max. And then, okay, so right max, or right R AI minus equals 1, and then if right max, no, if right R AI is equal to 0 and curm and right max is greater than AI, then we should set right max to AI. Right. Let me think. So we iterate through, we remove the current element from right R, check if right R AI is equal to 0. If it's equal to 0, and the max is greater than the current removed value, right R AI. What is this doing right now? So we take this, we remove it. If it's empty and greater, we set this, but it's not, so we do nothing right now. Yeah, this is correct. And then we need to update the left side by left R A I plus equals 1. And then we need to update the max, right? So kind of the same logic here. Why do I have curmax? This should be right. Huh? Where did I define this? Use right max. Right? So we just copy this. You need to calculate the max while left R, left max, then left max plus equals 1. So we move the bar, we add it to left R, and then we compute the new max, right? This is correct. And we subtract from the old max. Yes, this is correct. And then, finally, we should check if left max is equal to right max. Then we just break. We print out it's all of this stuff here. It's not L anymore. We don't need this. It's gonna be I, and then I plus 1, right? And then break. Else print -1. Why does it look... Okay, they recently updated this extension because it did not used to look like this. I kind of don't like this. Big text and everything. Index out of range. Left R. Left R is an empty array. Left R, okay, left R needs to be this as well, I think. Yes, because we're not appending. Left R is simply a count array as well. They're all -1. Why is that? Do we never get here? We don't. Do I have a logic error? Okay, so now it's a question of, is it a logic error or is it a syntax error? What the hell? We're still returning -1 for each, so it's gotta be logic error somewhere. Check the max. 1 1 then 0 1. Oh, this needs to be right max. What? -1, -1. These are working right. 2 1 8. Okay. For 0 0, it's simply just 1 1 2 2. 1 0. One, two, three, four, -1. For this one, it should simply be, first instance is here, right? It's 2, it's 2. So it should be 1 2 3 8. Is it I plus 1 plus 2? Okay, that might have been it. So one is 1 1 2 3. Which case is this? 2 2 2. 1 1. Yeah. Okay, I think this is right actually. Should be it. Submit it. Come on, Codeforces. Codeforces are quite slow today. There we go. Oh, we got it. Alright, next question. That didn't take too long. Well, actually solving the question probably took me all day, to be honest. I was looking at it a little bit in the morning, but then had to head over to class. And then I was thinking about it before at my club. This last meeting for the semester, which was a little bit sad. We just kind of hung out, didn't really do anything. I went to play pickleball after, got a cramp, but it's okay. We solved it out. Let's wrap up the day with like a few easier questions. We haven't done 1000 rated in a while. What is this question? Yet another mixed problem. That's right. I don't know if I'm gonna be able to do any contests this month. Like I really wanted to hit 1200, but all the contest times are kind of bad. Like all my finals are next week and stuff, and then these contests are in May. Like even these contests are kind of a bad time for me. If there was one on April 25, in 2 days. Maybe I can do this one? No, I have plans. They're all rough. We'll see. Maybe this one on the 30th? When's the 30th? I might actually have an exam on the 30th. Is it a Thursday? It is. Oh no. Yikes. Yeah, these are not good days for me. Okay. Whatever. Beautiful array. Stanley defines the beauty of an array A of length n which contains non-negative integers as follows, which means that we divide each element k, round it down, and sum up the resulting values. Stanley told Sam the integer k and asked him to find an array A of n non-negative integers such that the beauty is equal to b and the sum of the elements is equal to s. Help Sam find any of the arrays satisfying the conditions above. Each test contains multiple test cases. The first line contains the number of test cases t. Description of the test cases follows. The first line of each test case contains integers. Man, I always hate questions that give you a ton of input. I don't know why. It's just a pain typing everything out like that. I just want to start thinking about the problem, instead of setting up nkbs equals map int input split. I kind of want to try making a contest, although I don't know if I'm good enough. Maybe I'll make a div 5 contest. It's not even a thing. 800, a ton of 800 rated questions up to I don't know, 1500 maybe. I probably won't even be able to solve my own problems. Alright, Stanley defines the beauty of an array, blah blah blah, as the sum of ai, so each of the elements divided by k. What is k? K is a number given to us. Alright. NKBS. B is the beauty is equal to B. The sum of elements is equal to S. Help Sam find any of the arrays satisfying the condition above. So length n, floor each element divided by k. The sum of each element divided by k. If it's impossible, print -1. Okay. I don't have any thoughts right off my head. I think it's some sort of math problem where you have to rearrange these to give some sort of easier equation. But let's start by looking at some test cases. The second and fifth, sixth test cases. The example. It is possible to show that such array does not exist. Why? Please show me how they do not exist, instead of just saying that they don't exist. Third test case, 0, 0, 19, the sum of elements is equal to 19. So the beauty is, oh, this is a very important case. 0 divided by k, and then having one number that is the beauty, that the divide works for the beauty. What is our last input? S is the sum. So the sum divided by k. If the sum divided by k is the beauty, then we can just make this 0, 0, 0 S array, right? That's good to know. in the fourth test case, so sum divided by beauty is this one, is 535, which is not the k value. Wait, is this correct? Sum divided by k, so 38 divided by 4 is 9, which is not the beauty. So we can't do the 0, 0, 0 thing. We have to split this up somehow. Well, the floor divided by, we gotta get a beauty of 7. We can abuse the fact that we can abuse the floor divide. Right? To get zeros, to get close to the beauty. So, dividing by 4, I wouldn't do 29, anywhere from 28 to 32. No, 32 is 8, so 31. Anywhere from 28 to 31 will give a beauty of 7, and we want the rest to be 0. Yes, I think this is greedy. We simply just take the highest we can for this case, for like the last case, or or any of the numbers, right? It doesn't say it has to be in non-increasing order, right? So we simply just make the first number large. Does it? Yeah, we simply just make the first number as large as possible, and then make the rest zeros. And if we can't, it's impossible. I think that's correct. So our largest possible number for the first number is the beauty times k plus k minus 1. Oh, let's make this b. Beauty times k plus k minus 1. If we have, wrong question. So let's just pick a case. Is this one impossible? Yes. I guess we just have to pick this case here. Beauty is 7 times k plus 4 minus 1 is 28, 30, 31. So our first number is 31. For everything else, it's just 3 until we can use up the rest. All right, guys, I'm gonna do my routine bathroom break because I don't know why, but I always need to use a bathroom whenever I'm recording a video. I'll be right back.